New notes for 1.6. Today we're going to be talking about domain and range and two different types of notations to express domain and range, interval and set notation. Essential question: how does set notation and interval notation relate to the domain and range? So what is domain? The domain is all possible input values. Anything that is a possible input value for a function is in the domain. Domain starts from the very left, ends at the very right. So we're talking about left to right x values. The range is all possible output values, y values. So what are all the possible output values for a certain function? Range starts in the very bottom, ends at the very top. Y values. So what is set and interval notation? It's a method to describe the domain and the range. There's 12 basic symbols that we need to know. Okay, so we got greater than and less than. We have less than or equal to, greater than or equal to. We have some different notations that we're going to use. So you need to get used to these symbols and what they mean, all real numbers. We'll practice these as we go on here in the notes. So, given the following set of ordered pairs, remember everything you see on the screen needs to go in your notes. Given the following set of ordered pairs, find the domain and the range. We have 4 ordered pairs that we're simply going to plot onto the graph. That's where they are. This is called a discrete function. The domain is exactly -1, 0, and 2. Those are our x values. See, -1, 0, and 2. So you can see how there's 2 points at +2. So if that happens, you do not have to repeat it twice. You can just say 2 as once. Range values. Challenge yourself. What are the y values in this function? Hopefully you're thinking this point is at 3. This point is at 0. This point is at -3. This point is at -5. So those would be your range values. And that's how you would list them using those brackets. This is called a discrete function. The domain is precisely those values. The range is precisely those values, nothing in between. And like we said, if a number occurs more than once, you do not need to list it more than one time. Let's talk about what some of these phrases and symbols mean. So first up here, phrases for inequalities. That first one means less than, second one means greater than. This one means less than or equal to. You have this little line underneath here that represents or equal to. And then this one is greater than or equal to. When we have endpoints, so when graphing on a number line, this symbol here means we have an open circle on that graph. This one here is also going to be an open circle on that graph. You can see when we have an or equal to, that's when we close the circle. So we call it closed circle for each of these. Less than or equal to, closed circle. Same thing with greater than or equal to. For interval notation, less than here, so we're using those parentheses. Greater than, same thing. Less than or equal to, if something's less than or equal to, we use these bracketed parentheses that are straighter, not curved. And same thing with greater than or equal to. So how do we use set notation and interval notation? So here's a number line. So we'll have a number line example. We'll say what the inequality is. What does it look like in set notation? And what does it look like in interval notation? So we'll start with this number line. So you can see we have a boundary point at +4. And we're graphing numbers greater than 4 with an open circle. Since it's an open circle, like we talked about, it's just greater than 4. So we say x values greater than 4. All these numbers to the right are greater than 4, but not including 4. That's why we have an open circle. The set notation looks like this. So we just have our parentheses, x for x values. We have a little bracket here, and then next to here we say x is greater than 4. For interval notation, since it's just since x is just greater than 4, it's not or equal to, we want to use our parentheses here, the non-bracketed parentheses, because it's not or equal to. And then since our graph is shooting off to the right to positive infinity, right? That's what the arrow is indicating. We're going to have this infinite symbol. So that means our graph goes to 4 to the left, stops there. That's why we have this parentheses, not including 4, and it shoots off to the right forever to positive infinity. And we always use the parentheses when we have infinity, because we can never get or equal to infinity, because infinity means continuous forever, infinitely. Next number lies, and that's what that note says at the bottom. So next number line, boundary point -10, graphing numbers to the left of -10. So x, I'm sorry, not -10, that would be a -1, and then that's 0. So x is less than -1. All these numbers are less than -1. And we have an open circle here, right? So we're not or equal to, it's just less than. So the set notation, pretty much kind of the same as this, except now we have x for all x values less than -1. Interval notation, since it's going to the left to negative infinity, that's going to be your first value is negative infinity. How far does it go to the right on the graph? Hopefully you're saying -1, and since it's not or equal to, we should have parentheses on both ends, which we do. To the left to negative infinity, to the right to -1. It doesn't pass -1, nor does it get equal to -1. Next graph example. So we can see we have a graph that stops. We have endpoints at -2 and +5, and those are both close to circle. So we say or equal to. So x is greater than -2, but it's less than 5, and that's or equal to as well. So greater than or equal to -2, but less than or equal to +5. So that's our inequality, what it looks like. This is what it looks like in set notation. So you kind of see a pattern here. This is just a different way of notating it and writing it, right? So we have our brackets here, x, and then we have our inequality, essentially. And that's what we call set notation. For interval notation, you can see we have 2 boundary points. Does this graph go to the left forever? No, it stops at -2. Does it go to the right forever? No, it stops at 5. So we have 2 endpoints, and they're both or equal to. So we should be having the more square brackets right here, like this, because it's or equal to. To the left to -2, to the right to +5. And that would be interval notation. Last number line example. We have a graph that looks like it's continuous both directions, to the left and to the right. There are no boundary points, no restrictions at all. So the inequality, well, there really is an inequality because it's every single possible number. So how do we write that in set notation? It's going to look like this. X such that x is involved with every single possible number is essentially what that means. This essentially just means all real numbers or every number, but that's how you're going to write it in set notation. So the graph goes to negative infinity and positive infinity, and we always use parentheses for interval notation. In an infinite number of points on a graph. So can there be an infinite number of points on a graph? Given the following graph, find the domain and the range. Okay, so I want you to ask yourself, does this graph go to the left forever, and does it go to the right forever? Remember, this is just a small picture of this graph. This is continuous with arrows on both ends, meaning it does continue forever. So this graph will continue to the left infinitely over an infinite period of time, same as to the right. These parabolas, right, they start rising steeper and steeper, but they never completely get vertical. Well, they will never stop advancing to the left or to the right. So our domain is this, like we had explained on the previous page. Essentially, this translates into all x's such that x is in the set of all real numbers. That's what that means. So it's a fancy way of saying every possible domain x value is a part of the function. This is just how you need to write it in set notation, so it is important that you need to know that. Interval notation, our graph goes to negative infinity and to positive infinity, and we always use parentheses for interval notation when we have infinity. What's the range? Does the graph go up forever and down forever? Hopefully you're saying it goes up forever, because it definitely does, but does it go down forever? It does not. We have a restriction. It does not get below 0. It's coming down here. Does it hit 0? Yes. But then it continues to rise back up in the other direction. So the absolute lowest value that it gets to is 0. So we want to say that y is greater than or equal to 0, meaning 0 or higher. And this is what the interval notation will look like. Our smallest value is 0, and we have a boxed bracket because it's or equal to, and then our largest value is infinity, and we always use parentheses with infinity. Next example, let's write the domain. The domain, you can see, does this graph go right forever? It does. Does it go left forever? It does not. We are restricted right here. That's as far as it gets, positive 3. So x is greater than or equal to 3 is how we would write that. And that's set notation. And then interval notation is the smallest value is 3, the largest one is infinity. We need a more square bracket here because it's or equal to. 3 counts in the domain. Infinity is the largest number that the x values will get to. We always use parentheses with infinity. So what's the range? Does this graph go up and down forever? Will this graph continue to rise up over an infinite time? How about down? Hopefully you're saying yes, because you would be right. So that is in all real numbers. So the range is any y values is such that all y values are involved inside of the range. Again, this is a fancy set notation way for writing every single range value. So in interval notation, like this, let me ask you a question. What's the smallest y value? There is none, right? Every y value is covered over time. What's the largest y value? There is none, right? So we should have negative infinity as the smallest value and positive infinity as the largest value. And we always use parentheses with infinity. All right, ladies and gentlemen, that concludes our notes. Please summarize in a short paragraph what we learned today in our notes regarding domain and range.